Good afternoon and welcome to this Security Middle East Magazine webinar, which today is in partnership with industry leaders in data storage solutions, Seagate Technology. My name is Daniel Norman. I'm one of the senior solutions analysts at the Information Security Forum. And during the last couple of weeks and over the next few years or so, I will be collaborating again with the Security Middle East Magazine to contribute to some of the written work and content of the paper, as well as helping along the webinar pieces that the organisation is doing. So, for almost 20 years, the Security Middle East magazine has been the #1 voice for security professionals in the Middle Eastern market and in the region, and continues to lead the way for our audience to develop by directly engaging with industry leaders through multimedia platforms. Today's webinar panel, our stellar panel, comprises of video surveillance experts from Seagate, RoboVision and Network Optix, and will be leading the discussion around elements of smart cities and future trends in this particular sector. Our panel of industry experts will essentially be discussing the smart city elements and sharing some of their best practice and discussing future trends in the area. So touching upon the current landscape and future predictions for smart cities, any kinds of AI application in video surveillance in particular, the more detailed storage design considerations, and some more of the wider considerations for the interconnected ecosystems. Before I pass over to Jermaine to start the presentation and the panel discussion in more detail, I need to discuss a few house rules. So if you have any questions during this live presentation, please do raise your hand by using the tool at the bottom of your screen, and one of our team will reach out to you personally during the video. I will be chairing the Q&A after the 45 minutes, so we have around 15 minutes at the end of the presentation. So please enter any questions into that Q&A tab, and this webinar will be available on demand on our website and YouTube channel. If you're watching on demand and would like more information, please contact Gareth at securitymiddleeastonline.com. And now that's out of the way, I'm delighted to hand you over to Jermaine, Seagate Surveillance Sales Manager for the Middle East region and Head of Surveillance for EMEA. So Jermaine, without further ado, I'm happy to pass over to you.
Thank you very much, Dan. And I want to thank everybody as well at Security Middle East magazine for organizing this, and really thrilled to be here today. And like Dan mentioned, we've got a great lineup on our panel today. We're going to have a good conversation about smart city and video surveillance storage architectures. And we're going to be talking about some AI. There's a very small correction there. We've actually got Rob Dupre from VCA, and rather than the other company that was mentioned. So we're going to get into this straight away. And as Dan mentioned before, if you've got any questions, please drop them into the Q&A. We'll do our best to answer them as we go through. So we're going to kick it off getting all on the same understanding of a smart city, right? What is a smart city? What makes up a smart city? What are some of the key elements? And to kick this off, I'm gonna point this question at James and maybe ask James at Network Optix to give us his view of a smart city.
Yeah, for sure. So obviously, one of the first parts we'll talk about is exactly what is a smart city. It's kind of like a basic term. So for us, like a smart city is basically, it's where you use a lot of sensors deployed throughout an urban area to basically collect data, right? And then with that data, you analyze it to kind of see what's going on, rather than having to put physical eyes on it. You use kind of like systems to actually do the analysis of all the data. And then it gives you the option to execute. Sometimes automatically executed, or sometimes you can manually execute the objectives. So that's kind of your base level, right? And one of the things to remember now is the video is now the king. So where we used to use a lot of kind of dumb sensors, things like parking sensors that really just tell you, is something there, is something not there. Now we can use video. It gets a lot more granular in its detail. So we can use a camera to cover, entire streets. But we can also tell you what's parked there, what color the object is, what license plate it has. So the video is now really kind of moved everything to the next level in terms of what we can do and how much data we can collect, which is kind of one of the main importances of this, like doing this with Seagate, right? It's creating a lot more storage. So the key objectives, so if you can just jump to the next slide, Steve. So some of the key objectives that we see kind of a lot come up for these safe city projects. So, we've got traffic systems, things like being able to tell if a car's illegally parked somewhere in a city. If you've got thousands of cameras throughout a city, you can't have everyone monitoring it. So you want these systems to be able to automatically tell you something's blocking a road. And then once that information has been analyzed and tells you that there's a car that's blocking traffic and it's creating backups, we can then decide to execute what to do, right? That can be automated in terms of creating signage to divert traffic through different streets, or it can be a sense of alerting local authorities to go and get the car to move on. So lots of kind of like things like that with traffic systems in terms of traffic management as well. We can change the flow of traffic based on how much traffic there is in buildups. And all of this is now automated based off of what the cameras are seeing, right? So traffic is probably one of the biggest ones, joint with the public safety in terms of how safe cities are operating. So we'll move on to the public safety section. One of the things about our platform, which is a kind of a VMS platform, we kind of call it a situational awareness platform, in the terms that we tie in with a lot of different AI products. And Rob will kind of speak more to this later in the presentation with his AI that we work with. Rather than having, like we said, hundreds of people's eyes on thousands of cameras, which is obviously almost impossible to monitor that much cameras, all this data is being assessed by AI algorithms, and then it's telling you what you need to be able to see, right? You're not having to sit there and look for things. It's actually saying, like, this is something that needs your awareness or your attention. So that's kind of where our platform's heading towards, is we don't want people to sit there looking at dumb video effectively that has nothing to see. We want a couple of people sitting there that only see critical things that matter. In that way, it helps a lot with crime prevention as well, right? So like things like you're not sat there staring at a camera where nothing's happening, when you could be looking at a camera that has a potential threat going on, with behavioral analysis, kind of AI and stuff like that. So kind of with public safety, there's a whole lot we can do, including automated responses, which ties into kind of the next one, the emergency operations. Things like if there's fire detection, it can automatically alert the fire or the kind of like emergency operations call lines and stuff to then assess it before anyone's even called in, because we can now run fire detection analysis on cameras. So especially in parks and urban areas of lower population, where industrial estates and stuff at nighttime, where there might potentially be fires, rather than having to actually have someone's eyes on it, a camera can detect there's potentially a fire using smoke detection or flame detection. So it's kind of that prevention side as well for emergency operations, means that they can get there earlier, they can deal with the issues a lot quicker, and then you kind of don't have that backlash of events if it's kind of left to alight a lot harder or faster. Even in terms of when someone calls, an emergency service, if they're calling it from a public area or from a location within an urban area, the emergency operators can actually grab the camera feeds from that area as well. And they can see any alerts or issues that are going on, so they can straight away get eyes on where these calls are coming from now. Whereas before, you kind of just have a voice on the end of the line and not really understand what's going on. So it's kind of really allowing people to assess in situations a lot better and kind of create better objectives that actually kind of solve issues a lot quicker. City management is quite important. Sorry, go on. So city management is
I've got it. It's good. Yep.
City management is obviously less about safety and traffic systems and things, but it is also a large part of making cities more livable and usable and friendly. Even just small things, right? Like you can have like garbage maintenance, right? When cameras can detect, can be trained to detect that trash cans are getting overfilled, or that there's large areas of litter on the floor. Using object detection, you can automatically notify the waste management services, and then they can get out there a lot earlier than they would be, because it's filled up a lot quicker than their routine scheduled. Or even things like parks that are potentially having flooding or burst water mains. All these kind of things can be detected via AI way before someone calls it in or someone decides to notice it and can straight away alert the service that is related to. You know, so if it's city management and there's a burst water vein, they can get the maintenance, kind of city maintenance guys straight out there to fix it a lot quicker. Therefore, your traffic systems aren't as impacted because you've got the issues resolved a lot quicker, so you don't have your traffic back up. You can also, as you've detected it, rather than waiting for traffic to back up, you can divert traffic a lot earlier, right? So all these things kind of allow you to create a lot better flow and kind of a usable and more kind of friendly city environment, right? And then kind of the last one that we see is the data collection, right? And this is a big one that we work with Seagate for, is you can do city planning, you know, you can do long-term advertising throughout your city. We've worked with customers where they wanted to do advertising on bus routes. So they collected general information of all the people that were walking in certain areas. So on bus shelters and things, they could put advertising that was directed towards the crowds that were in those areas. But also, like we said, for city planning, if you've got a park that's going to be converted into a building, you know, what needs to be put there. You know, you're not going to put a playground in the middle of like Wall Street, for instance. You might put a playground next to a school. In the middle of Wall Street, it might become a bar, right? Like who knows what it is? But the idea is that the city planning allows that long-term data. And it's not, you can't just have a month's worth of data for this information, because otherwise you don't know what anything can happen in a given month, right? So this data needs to be kept for years and years and years. So then you can come back and you can run analysis on it to actually then determine, like, okay, we're going to be funding extra urban activity in certain areas. What do we need to put there? Let's go look at our data and decide what the best thing is to put there. But like I said, you can't do it on a month's worth of data. It's not enough data to collect. So you need a couple of years worth of data to say, all right, in that area, this is the trends and things that we've seen. So realistically, if we're going to put budget into improving this area, this is the kind of improvements that would work best. And that data has to last for a long time, and it's a lot of data. And that kind of is where we work with you guys a lot, right, at Seagate, to basically store all that data, because we're talking, you know, not just terabytes, we're talking petabytes of data we've been storing for years and years. But it's all important because it helps you with that future planning of a city to really make sure that it's going to be as smooth and kind of it's future proofed as well. So you're not going to do something that later down the line is just going to be worthless again. So that's kind of the key objectives that we kind of see of the safe city and kind of how we describe it. And as I said, the video is always king for us, being a video platform, but it does give you a lot more information, and I'm sure Rob will talk more about that later. So I'll hand it back to you on that one.
Yeah. Great. Look, it's a really, really great dissection of a smart city, and I had kind of some follow-up questions about, you know, is this kind of all theoretical and nice to have, and, you know, is this real life, right? But I think you really answered it in your overview just there, right? That it's delivering some real benefits to cities and to councils, and it leads us nicely actually into kind of the next question about data. You know, you talked about data and this data collection, and let me put another question out there. Maybe point this one at Steve. Steve, you know, when we look at a smart city and we start talking about data, you know, what is the connection? What is the importance of this data? What have people got to think about when they're thinking about data and smart city? Could you talk a little bit about that for us?
Yeah, of course. Yeah. Hi, JC. Yeah, and thanks everybody for joining. Good afternoon. Yeah, so just to touch on what James was talking about before, you know, to me, a safe city is one in which, you know, data and technology can be harnessed to basically keep residents safe within that city. You know, critical national infrastructure protection, city surveillance, emergency operations, which James touched on before, you know, road information systems all contribute to providing a safe city environment or a smart city environment. And as we know, all these different subsystems create, you know, huge amounts of data, and this data needs to be obviously managed, analysed, and stored securely. And that's typically where, you know, Seagate really come into play. The slide you see here, maybe many of you have seen this slide before. This is taken from a recent Data Age 2025 report, which was published by IDC, and a report that was sponsored by Seagate. And this report basically looks at what is driving this sort of massive growth in the global data sphere. So IDC forecasts that the global data sphere will grow to 175 zettabytes in 2025. And just to put that into context, you know, Seagate currently are providing over 50% of the global demand on media, mainly hard drives. Oh. And in the last 12 months, we shipped just short of half a zettabyte. So we're only sort of consuming about 1 zettabyte of storage globally currently, and the growth is going to go up to 175 zettabytes in terms of data being generated. And of course, we know not all that data is going to be stored, but you know, a percentage of it will. And when we look at our industry, you know, IoT, embedded systems, video surveillance are going to be all key contributors to you know, to that growth. And that's where we typically see the link. Also, the embedding of compute power now that we're seeing in a large number of endpoint devices, specifically as well used in video surveillance, will also continue to fuel that massive data growth in the coming years. Excuse me. So just moving on, I mean, you know, this slide is just to really message to the audience that Seagate is changing. You know, Seagate was once known as a device manufacturer, and we're now definitely moving into a new era where we are becoming a true solutions provider, and with a longer term goal of crafting a seamless edge to core storage platform. So our current portfolio offers edge to core solutions with traditional HDD and SSD products like Skyhawk, Skyhawk AI, Exos and Nitro that you see on the slide deck here. You know, and Skyhawk and Skyhawk AI, for example, are optimized for what we would class as traditional video surveillance applications. We've recently launched our high density storage solutions under the Exos and Nitro brands. And these enterprise solutions basically consist of all flash, hybrid, and all disk HDD arrays, typically in the format of either JBOD or SAN. All our disk arrays basically scale up to approximately six petabytes, but you can also scale out and add obviously additional storage or additional clusters when and where required. All these SAN our SAN technology basically is deployed with active controllers for data protection. And also we're able to deliver over 5 gigabytes of sequential write and 7 gigabytes of sequential read performance, which is ideal for that sort of large scale, you know, high camera counts, high retention period type of application where we see within safe and smart city deployments. I know later James from Network Optix will be presenting the results of a recent stress test where we've actually used our 5U84 SAN together with the NX VMS platform. And the purpose of this test was to look at potential use cases. And of course, one of them scenarios would also be safe city and smart city types of applications. Excuse me. So as we see systems becoming more complex and the overall solution truly integrated, we also see the need for efficient and reliable data storage. And this is becoming ever more critical. But that's not to say that obviously every system requires large scale shared network storage to function optimally. And we also see, you know, there's a lot of high performance video appliances and MVRs typically on the market today that offer, you know, video capture, analysis and recording, which are ideal for sort of small to mid-size video surveillance environments. However, there are installations where, you know, a storage area network or SAN infrastructure brings a new and needed level of flexibility, scalability and protection. So enterprise class surveillance environments typically utilize large numbers of high resolution cameras. We often see, you know, extended video retention times, often several months or more. And because of this requirement and this specification, the requirement for data storage or to have a storage solution that is more robust and expandable over time, typically compared to, you know, traditional NVRs and sort of standalone siloed units. So SAN offers typically a really good alternative. So SAN enables enterprise level security deployments to integrate multiple recording appliances, typically what we would class as recording appliances or network video recorders, into one shared storage network, typically using either iSCSI or fiber channel connectivity through a separate network switch. And as video surveillance infrastructure increases, you know, storage systems or expansion units can be easily added over time to basically increase that capacity. And the SAN architecture allows for greater flexibility to upgrade hardware without the typical heavy lifting. SAN systems also provide, you know, increased redundancy, eliminating single point of failure that we typically see in sort of, you know, standalone appliance-based or NVR-based environments. And the key takeaway here is that, you know, Seagate typically delivers a significant element of that sort of safe city or smart city data flow. So yeah, unless there's any questions, I'll hand back over to you, JC.
Yeah, thank you, Steve. Really interesting. I think the pieces are coming together as well, right? So we've got like this, one of the applications of like a smart city, which is integral in a smart city, is all of these endpoint devices, right? Capturing all of this kind of data that needs to be analyzed. And I guess, you know, all of this data then has got to be stored. I get the whole idea of Seagate moving from, you know, single devices, putting in a hard drive and an endpoint device or an edge device, and moving into this area, right, of kind of solution storage or scalable storage, SAN storage, where you can start saving petabytes of data in one of these solutions right here. I think all the pieces start coming together. Is you know, just having a look at some of the numbers that you talked about there, Steve, you know, 175 zettabytes by 2025. Seagate is supporting half of it or something last year, I think you mentioned, right, at half a zettabyte. So, you know, is this enough, that these SAN storage devices that we're moving into, is that going to be enough to provide the kind of storage that is required for where this data curve is going? Is there any other technologies or innovations or anything from Seagate or the other hard drive manufacturers that is going to kind of enable the storing of all of this data that's got to be created, retained, analyzed?
Yeah, of course. I mean, you know, there's a global demand from multiple segments, including video surveillance, and the demand is to typically provide, you know, the highest density storage media for the lowest cost. I mean, what us and our, you know, competitors are, you know, investing in or have been investing in for many, many years is different technology that allows us to basically increase areal density. And areal density is specifically directly related to our spinning disks or our HDDs.
Yep.
One of them new technologies that we've been working on at Seagate for well over 10 years and has already been released to market, and we'll start to accelerate that launch into, you know, during this calendar year, is a technology called HAMR. So that's heat assisted magnetic recording. And in a nutshell, what this technology allows us to do is increase the areal density on the actual platters inside the hard drive. If we increase the areal density on the platters, we then increase the actual capacity of the hard drive. So over the next few years, we'll be seeing 20, 30, 40, 50 terabyte plus devices out in the market.
Wow.
On single HDDs. And of course, as Seagate is a leading manufacturer, and all these solutions you see here are Seagate end-to-end. We call it vertical integration, but all the technology you see here on screen is Seagate end-to-end. So we have this first-to-market approach as well. So as we're bringing out new technology like HAMR to the market, these devices will obviously already be or automatically be integrated and optimized inside these types of SAN solutions. So that 6 petabytes well, just over 6 petabytes, which is our current capacity on our this 5U84 SAN that you see here on screen. That's based on our 18 TB drives. As we move into 20, 30, 40 TBs, you can see, we're going to massively increase that storage scalability.
Got it. Thanks, Steve. Thanks for that. And
no problem.
Maybe we should talk a little bit about AI, right? So we've got the data, we've got our way of storing the data, and we got to some talk about an analysis and understanding the data. So, Rob at VCA, so happy that you're able to be with us today and give us your insight on this. What is the contribution of AI? What's the smart part of the smart city? Maybe you can talk a little bit about that for us, please.
Yeah, sure. Thanks, JC, and good afternoon, everyone. Yeah, I think obviously data is the key word, I think, here. And for me, the two fundamental principles when we talk about video content analysis and relating to smart cities, one is that metadata and the algorithms that produce that metadata. And the second, of course, is the ability to aggregate that metadata across all of the devices or the algorithms that you're running, which gives us the ability to gain insight that simply wasn't possible when you look at cameras from an individual perspective. So I want to start very quickly by just running over some of the sort of prominent and applicable algorithms to the smart city scenario. It's certainly not exhaustive, but it's a good indicator of what's going on. And broadly, there's sort of two categories. The first is kind of event-based. So this is the idea that something has happened, an algorithm is running to detect that event. So things like behavior recognition, maybe there's a fight, maybe someone's loitering in a place they shouldn't, and we want to generate an alert on that and action that particular event right now. And that extends to things like scene understanding. So we're starting to see algorithms that can detect just abnormal events. So maybe not something specific, but an indicator that something's not quite right. Or predictive analytics. We're looking at maybe traffic, it's starting to slow down. That could be indicative of a problem that's forming. Let's generate an alert before we see something sort of fundamentally wrong and try and action that a bit quicker. The other side of the event generation and the algorithms is really this concept of detection, classification, and tracking. So what we've seen now is huge developments in the accuracy of things like detection and classification algorithms. So finding the object in the scene, labeling it as the type of object it is, person, vehicle, maybe the type of clothing, the color, all kinds of kind of properties of the objects that we see. And of course, then the extension to that is tracking those objects. So where is that person going in the scene? Where is that car going? Which obviously allows us to do things like monitoring things like intersections. Is that car turning left? Is he stopped and then turned left? We can start to infer kind of logical behaviors or more complex behaviors based on that. So the important thing, I think, then is that we look at the aggregation of that. We have this distributed network of cameras that are all running algorithms at the edge or near the edge. And the power of the smart city is really bringing that data together and aggregating and storing that metadata into the centralized platform, like, say, for example, the VMS. One really good example of this is forensic search. Let's take a classic example of someone's lost their child, for example, or we're looking for a specific person, and we might have 1,000, 2,000, 3,000 cameras. We might have an hour window of which this person has gone missing. That's 1,000, 2,000 hours of footage that we would potentially need to review manually, which it's just not feasible. So having all this metadata that we generate around object detection, so things like the color and maybe age, so adult, child, things like that. Now we can start to apply these sort of forensic searches to say, okay, well, now just show me from those 1,000 cameras, all the cameras that had people in them, all that had cameras that had maybe white clothing in, all the jackets, all the children, and we can really filter that data down to something much more manageable, and maybe even pick up an ability to build up a picture of where that person has been. We've located the child in camera 1, they were walking to the left, that's onto camera 5, and we can start to build up a picture of maybe where that child is now. And so that's a very practical example from an immediate perspective. As James alluded to earlier, Trend analysis is another big side of this. So we have this information that we've collected, this metadata that we've collected over time. So things like traffic information, the number of people that have gone past a shop, or how fast the traffic is running. And of course, we have that data for a period of time, days, weeks, months, years. And so now we can start to do comparisons and say, okay, well, maybe a city planner has made a change or is looking to identify where the pain points are in a particular intersection, for example, and we can use that data to validate that there is a problem, or maybe that they've made a change and that change has had a positive impact in comparison to, say, the average speed or the time of the speed last year, or maybe even from the perspective of planning a new city. Maybe they want to try and pick the best parts of various different cities and infrastructures and reuse that. And that really alludes to the image in the top right there in terms of this kind of structure of decision support. You know, we mentioned situational awareness, and that sort of ties into that in terms of we have this metadata, we can apply to that things like context and meaning and insight, and as a result, we can make decisions and action that data in a way that really wasn't possible before. And then very quickly, lastly, there's the pragmatic side of it. You know, we have this platform to manage our devices. We have the ability to monitor the health of hardware. Is the temperature correct? Is it still producing video? Are the algorithms running? Firmware updates, things like that. And then, of course, there is this kind of reuse of the data. We have the ability to retrain our models. We're collecting data across all of these different algorithms. And we can fine tune those algorithms for the very specific environment that we are in. So as a comparison, if I have a city that maybe has a lot of open spaces, a lot of grassland, for example, maybe my algorithms wouldn't work as well as if they were in a built up, very overpopulated environment. And so now I can reuse the data that I'm capturing to retrain those algorithms to make them more efficient.
Fantastic, great. I had a question that was in my mind, Rob, if you can help me with it. So this kind of modeling and training, is this done by is this done in isolation? You know, if I'm part of a city council there, I've got my deployment of cameras about. Do I need my own cameras to do my modeling and my training with my software on my servers, or am I able to kind of purchase models that have already happened in some other city council somewhere else and kind of apply it to? So I immediately get the learning, you know, in my own council. I don't know if that question makes sense, but
no, it absolutely does. And it's one of the biggest challenges for AI. And so yeah. AI, as a very general comment, is based on the data that you train it with. So one of the things that was a real problem for surveillance-based algorithms was that all of the massive data sets that we needed to train our algorithms were all based on stuff that you would pull from, say, Google Images. And, you know, if I'm looking for children or people or to try and define cars, it's a very different image. Say a person who's taken a photograph outside of, you know, the Houses of Parliament, for example, versus the grainy, greyish image that you would get from a CCTV camera. So, so yes, you can start with models that are trained on that kind of agnostic data that we get from really anywhere. And then it is about this fine tuning. It's about taking that model architecture and that initial training and now saying, well, okay, actually what a car really looks like for our environment is this kind of 45-degree angle. It could have a relatively high quality image, or it could be a bit more grainy. And so this kind of retraining and fine tuning is a major part of making the algorithms, you know, from something that works pretty well just on the basis to actually being something that's really reliable and generates a lot of good metadata.
Great. Maybe one more follow-up question. Sorry, Rob, really interested in this. If
Sure.
Installer or, you know, maybe an end user or something, they want to maybe get advice, right? That they've got competence at putting in hardware, setting up software, but that they need to actually get advice about this kind of AI, about modeling, about generating their own models or importing from somewhere else. Are they able to kind of reach out directly to VCA to kind of get guidance on this, or you know, where would they go to kind of get some advice or instruction or learning
Sure.
about kind of AI usage? And
yeah, I mean, so these kind of webinars are great, and we do a number of them as VCA and with our partnerships with people like Seagate and NX, but in effort to kind of inform the market in a lot of instances. analytics is a prime example of something that was traditionally quite oversold. It was something that would solve all your problems, and you didn't have to do anything with it, and it just worked. And it's becoming more and more true, but we're not quite there yet. And so yeah, we're very happy for people to reach out and ask us questions, and we're happy to help present or even give examples. If there's data that people have, for example, and they're in their environment, maybe they have a traffic scenario that they want to see how good our algorithms run on, then a good algorithm company such as ourselves would run that data through, provide you those results, talk you through it, why it works well or why it doesn't work well, and then offer advice on how to optimize that, whether that's camera positioning, whether that's camera format, or maybe it's the type of algorithm that's used.
Got it. Thank you. I see some more questions coming in, Rob, about AI and accessibility, availability, costings, and that kind of stuff. We're gonna have a look at it later on, okay, Rob? I really appreciate you kind of giving us that insight. We're gonna move on a little bit to about storage. I'm looking at storage again, right? So, we've talked about the mass of data that's coming, different kinds of data, I guess, right? With data needing to be analyzed, and kind of metadata and so on. Maybe a question to you, Zubair, you can help us. What should be considered when we're designing, the storage solution for a smart city? What should people think about?
Thank you, JC, for the question. Good afternoon, everyone. From a storage design consideration point, there are multiple factors that needs to be considered when designing a storage. But however, there are two key areas where the compliance is a must. One of them is the local regulatory authority, where in many countries in the Middle East especially, there is a legislative requirement with regards to storage in terms of frames, resolution, how many days of retention, and other specifications around it. And in addition to that, the second one is the compliance to the security consultant project specific requirement, which is based on the end customer needs. These two factors becomes a must for any project that is being commissioned or being executed. Followed by which the other areas to consider is the capturing devices, the storage required at the edge or the cloud, or maybe in some cases at both the places, edge and the cloud. Now, with the explosion of endpoints, the data being captured by various devices, some of them are the cameras, the drones, maybe phones, maybe wearable gadgets. In a video surveillance, nowadays the 4K cameras are becoming a new norm. Obviously, the higher the resolution, the more the data storage requirement becomes. And video is one of the bigger contributors for the storage requirement, especially from a video surveillance perspective. Once the data is captured, it needs to be transmitted, for which we need an appropriate network infrastructure in place based on the application and call to action clarity. The data should be stored at the edge or the cloud, or in some cases, both of them. Now, referring to an edge refers to the data that is being captured and processed at the nearest point to the endpoint. And it all depends on what you want to achieve out of that data. And if you're referring to data capture where you want to get some sort of analysis, or where you want to look for answers to certain specific questions, then generally it is advised to keep the data at the edge, where you have less latency or no latency in many regards. Then there comes the extended storage requirement for non-critical areas or non-critical information. Like, for example, you want to have a data at the edge for 1 month, and for certain key critical information, you would like to extend that to another 1 month, which goes into an archiving. Now, archiving could be a remote location, or it could be a cloud kind of setup. Especially from a large enterprise project requirement, in most of the cases, it is recommended to have a scalable storage, whereby in future, when you want to add or improve or refresh your infrastructure, you need not change the entire backend storage requirement. So that's where the new legislation in most of the high-end projects comes into picture, where they say, okay, we want the systems to be scalable based on an open protocol, where we really don't need to change the major infrastructure setup in place. It also asks for additional cameras where it can just becomes a plug and play around the requirement.
Got it.
In certain, yeah.
Sorry, I didn't mean to interrupt you, Zubair. Had you finished there? Covered everything you wanted to cover?
Yeah. If any questions, I would be happy to answer it.
Yeah, I just think it's really interesting, you know, that there's so many things to consider, right? I mean, just made a little note of some of the things that you mentioned there, and you know, resolution of cameras, and the cameras resolutions I think have been increasing, and we all love to see, right, the next high resolution camera, but it has a real impact on storage, like what you're telling me, and obviously the proliferation of cameras, and the kind of network infrastructure I thought was very interesting as well. I live in an area right now, and if British Telecom are listening, I'll tell them right now, you know, we're not happy with the network infrastructure out in my little village here, but having a camera around a house is one thing for storage, but I guess if you're wanting to record data from hundreds or even thousands of cameras across a city into a storage application, then the proliferation's got to be considered. So very interesting, and thanks for that, Zubair. Maybe I open this up to all the panelists. I don't know who can talk about this, but we're talking about the ecosystem, right? And we can't just talk about storage by itself. You can't just talk about the VMS by itself, or cameras by itself, or the AI by itself. All of these things, I guess, need to have some kind of working together. You know, what's the importance of the kind of partnership between kind of these companies or applications? I wonder if someone could talk to us about that.
Yeah, as I'm going to go into the next slide, I can kind of jump onto that one. So we do a lot of like partnership work, and kind of like you were saying, we're just the VMS, right? We don't intend to do like AI like a lot of VMSs do and things like that, purely because we're really good at making a VMS. So that the importance for our side is like having these strong partnerships with AI company like Rob at BCA, and like obviously from the storage side with you guys, is you can make much stronger and more robust solutions, right? Like everybody's an expert in their own field, whereas when you try to be an expert in every single field, you tend to fall down, right? So for us, the importance of kind of having those key partnerships and actually doing these testings, which we'll talk about in a second with one of the last tests we did with Seagate, is really kind of stress testing and showing that for the importance of deployments in things like safe cities, right? We're not talking about a small 4-camera system. We're talking about systems with thousands of cameras. So these systems really need to be stress tested to make sure that they're resilient enough to have maximum uptime, and really be the right solution for any kind of environment that's going to be under that much strain. So these partnerships to us are important because we can deliver the best solution possible for the customer, but also make sure, like with the work between our companies directly, allows us to make sure that it's also resilient and stable enough for any environment. It's kind of the importance that we stress, right, with that kind of partnership and the fact that everything's tested.
Great stuff. Yeah. Thanks, James. Wasn't sure you come to an end there. Yeah, I can see this kind of setup here that you've got of this stress test. I wonder if you could just spend just a couple minutes, maybe just talking to us a little bit, maybe about this particular case, and how would you go about, you know, doing a stress test, you know, to see how compatible everything is.
Yeah, for sure. So obviously, when we first started discussing kind of our cooperation with Seagate, it was kind of on a device level, and now we've kind of moved it into obviously looking at the actual storage devices rather than just the hard drives. So one of the things we wanted to get done was actually confirm, how much can we do with these? What level can we push them to really kind of make sure that we're confident in what we're talking about when we're doing joint conversations with these cities and things. So for this one, what we did was in a data center in Singapore, we actually hosted one of the Seagate chassis in there, the 5U84. And what we did was we had just a standard server split into 10 VMs, and we put 1,000 cameras on it, right? So our test was basically to see how much data we can push to a Seagate storage array without having any frame loss or anything like that. So if you can just jump to the next slide, Steve. So this is just a quick overview of our setup, right? So like I said, we had one server, so we didn't have 10 servers. We had one server split into VMs, and we had 1,000 cameras on it. So each VM had 100 cameras. They were running at 4K at 30 frames per second, right? So we don't need much better resolution than that. 4K at 30 frames per second gives you most of what you need. So we did all that on a single device. And then what we actually had was we had it live recording directly to the Seagate 5U. So we didn't have any internal storage on the servers that we hosted the cameras on. We had the direct connection via iSCSI to the Seagate device to see exactly how much data we can really push. So we had quite a lot of storage in the device. So if you can jump it to the next slide, Steve. So these are the results that we captured, and we did this over a few day period to really make sure that we stress tested it properly. So actually I think we did it for 30 days straight, but we took the results for a 24-hour period. So you can see from the statistics, we had an 89% usage on our server, but we were running 1,000 cameras, right? That's actually pretty decent for a single server. The average throughput of all the cameras, including the dual streaming. So technically we actually had 2,000 cameras because we take 2 streams from every camera. But the secondary stream is a lower resolution.
Throughput, right?
Yeah. So total throughput was, almost a gig and a half megabit, a gig and a half per second through the network. And we managed to only get 0.005% frames dropped when we analyzed the Seagate storage, right? So we're saying basically, if you have 1,000 cameras on a single server sending back to a single storage array, you're only going to lose pretty much no frames over a 24-hour period, right? Which realistically isn't even the setup you're going to do. You're not going to have 1,000 cameras in a single server, and the chances are you might have a couple of storage arrays anyway. So we really kind of put this to the test to make sure that we can deliver what we say we can deliver, right?
Yeah. So I mean, I take 2 takeaways from here, really, and Steve and Rob, Zubair, opening this up to you as well. I mean, on one side, it's an incredible test result, right? Incredible that the software and the hardware is actually able to deliver this kind of throughput and successful frame capture. On the other side, I guess for the kind of installers, end users, those that are listening on this call, it's good to know that companies are able to kind of work behind the scenes, right? To go and do this kind of testing and this kind of demonstration, do this kind of heavy lifting, so that we can reliably come back to an installer, an end user, a consultant or whatever, and say, hey, look, we've done maybe what might be difficult to go and practically do out in the field, right? We've kind of done it behind the curtains as manufacturers together. And I guess, maybe pointing back to you again, Rob, on the AI side, this is testing kind of like throughput and captured frames, but if we wanted to also involve kind of AI metadata streaming and the ability to kind of capture the stuff that the VCA technology captures, that can also be kind of pre-tested and predetermined before time, I'm guessing, right? It's a statement, but it's supposed to be a question. I mean, are we able to do that kind of pre-testing on the AI capability as well?
Yeah, of course. I mean, so a couple of things. One is that we, from an integration perspective with NX, we have a plugin, and the concept behind that is that we will pass our metadata to the NX system, and NX handles things like the storage and the management of that data. And as we can see, they're obviously very effective at managing and controlling that data. And so in the same way as we are not a VMS company, we don't want to store video, we don't even want to store metadata. We want to pass that off to someone who knows what they're doing. And so, you know, the relationship between NX and Seagate is great, because it illustrates that they know what they're doing with their data, they know how to storage, and they know how to keep hold of that stuff. And the other thing to mention, of course, is from a metadata standpoint, it is much less in terms of throughput. You know, we don't do storage of frames, we don't do really anything to do with the video. Once the algorithm has run its inference and decided what it needs to decide on a particular frame, all you get out of that is just classification and text data. So one, the load is much smaller, but two, it's also entirely anonymous. You know, we don't have any concept of tracking a particular person or the way they look or anything like that. And so, you know, you get two advantages: much smaller data, and it's all safe and sound, GDPR compliant, etc., etc. So, yeah, as I said, these kind of relationships are great, and having a plugin directly with NX allows us to do that kind of back end testing and make sure we're all singing from the same hymn book, as it were.
Great, yeah, thanks for that. I mean, Steve, this is not, I'm guessing this is not like lucky, right? It's not like fluke that, you know, Seagate had built a really good product. We so happen to have partnered up here with a really great VMS and AI kind of plugin. You know, how does this stuff all align? You know, how do these companies actually make sure that this kind of stuff works smoothly? Or put in another way, if there was an issue, right, you set up this kind of test and it didn't do what you expected it to, we expected it to do, you know, how do these companies kind of work together to kind of solve that? Maybe you can just give us a view behind the curtains, right?
Yeah, of course. I mean, when Seagate, you know, first started to really focus on this sort of scalable approach, or these large high density storage solutions, specifically in the video surveillance market, I mean, there's a level of credibility. You know, when we talk about an ecosystem, typically we talk about multi-vendor approach, we talk about best of breed, we talk about predictable performance, and we also talk about choice from an end user point of view. You want to choose the right technology, and you want to bring it all together in one common platform and make sure that it's optimized and it all works together. So from that credibility angle, we knew that we had to go out and, you know, validate and certify our solutions with some of the big global leaders. And, you know, our relationship with Network Optix has been there for many years. And this is just one sort of use case and one really good example where we've actually taken our solutions and actually validated it and actually put it into this sort of, you know, performance, or through this performance criteria. Because if a customer comes to us and said, look, you know, I'm reading your data sheet and, you know, potentially you can stream thousands of cameras through, you know, one of your SAN units, well, that's great off a data sheet, but what's it look like in real life terms? And I think, you know, where these stress tests really come into play is we can actually, you know, bring out a performance specification, a solution brief, reference architecture that actually validates our solution with, you know, a number of ecosystem partners. And I think, you know, that predictable performance is what customers really want. So I think that's really the main takeaway. JC, you're on mute.
Oh, I can't believe I fell for that on this one. Oh, dear me, rookie mistake. Sorry, everybody. So, look, I think this is I've learned something out of this session, and really appreciate all of your inputs. The importance of a partnership and collaboration, I think, has really come out at the end, you know, and what that kind of delivers. It's important as well for our listeners to know that you can also join that partnership. You can become part of the partnership. You can find out more on our website about our surveillance applications, but you can also click on the link. I think it's available later, or copy this link into your browser, and you can become a partner with Seagate, which kind of opens the door into all of our connections with different manufacturers and design reference architectures and so on with different solutions. You get all on the inside of that and can get hold of that information and talk to an expert, etc. So I really recommend everybody who's wanting to know more or to get closer, not just to Seagate, but to our partners, to go join that partner program with that link below. I do see some questions in the box. So what I think I'll do is I'll sign off here and hand back to the team at SME. And just from me, just want to thank everybody for taking the time to listen and to be engaged. Thank you.
And thank you to the rest of the panelists. Some really insightful insights really into some of the concepts around smart cities, data storage, and different elements of that discussion. So thank you very much for sharing that with us. We do have a few questions that have come in from the audience, but I'd like to start with some of the other questions that I've kind of been thinking up as we've been going along to kind of fill in some of the areas that you've touched upon. So I'll make them generic. So if anyone wants to jump in and answer and give their perspectives, please do. From my perspective, at the ISF, we create threat forecasting reports, and one that we created back in 2019, which gave a prediction for 2022 and 2023, was that the concept of smart cities and behavior analytics and the overall monitoring would experience some sort of backlash, either from society or regulators alike as well. And what I mean by that is that there is, I guess, an invasive nature of information collection and analytics on people. How do you balance the need to gather that information for your own requirements with privacy rights and privacy regulations? And that's an open question to the floor. So I've noticed Rob's popped up.
Yeah,
Rob,
I mean,
let's give your perspective.
If no one else objects, I'll jump in just because I think we're quite close to this, I think. And you know, there's two sides to this. One is legislation, and I think rightly we're now starting to see countries kind of catching up with the technology. So people like the US, where you have seen real throwbacks against things like facial recognition technology, especially during all the riots and uproar from last year. And you know, I think it's right. You know, I think there is, with most of these technologies, they are developed with good nature in mind. You know, facial recognition specifically has a lot of really good use cases, but it also possibly crosses a line that maybe is too far for certain areas and industries. And so, you know, typically I think a lot of AI companies will basically need to make that decision internally about what they will and what they won't do. And as a result, they will limit where they can and can't apply their technology. So for example, we don't do facial recognition. We do face detection because, you know, there is a use to being able to identify that there is a face in a screen. But the idea of being able to track a person and link it with an identity for us is one step too far. And so I think it comes down to legislation and final use cases, because as I said, you know, things like, you know, that example I gave in terms of lost child is a really good one. You know, if you had the ability to have a facial recognition algorithm that could immediately tell you exactly where that specific person was, you do have the ability to detect or find that person in an environment very quickly. But you have to balance that against the other requirements of the wider population and how happy they are with that. And I think the other thing to say is that there are other ways around that. You know, so in that forensic search example again, you know, we can do that in other ways. We don't have to have that invasive algorithm that's working. We can do it using other technologies as well.
Excellent, thank you, Rob. And I've noticed James has appeared as well. Would you like to jump in here as well?
Yeah, I'll just add one section to it. So in some ways, some of the AI actually assists in data protection, right? Like in a lot of scenarios in cities, the cameras are existing already, and they're just freely available for anyone in the operating room to kind of to monitor. And some of the cases where we're using AI, you're not actually having any physical eyes on any of the video. You've actually now got pixelization of people. So in terms of in all the video, the AI is actually pixelating people, so you can't see who they are. And the only time that you actually are allowed to see who they are if the AI has determined that that person's done something wrong. So then on a larger scale, you're actually getting more kind of like restrictions on what you can see, because it's only the AI that's allowing you to see certain events, and you can't see stuff that you don't need to see, if that makes sense. So in some ways, it's actually protecting people's data further with AI as well.
Excellent, thank you, James. So I've got a few other questions here as well, and I just want to expand on one of the questions that came through in the chat function. I think it boils down to, the question really is, smart cities, is it an emerging, are developed nations, I guess, more likely, and will that kind of gap between developed nations and emerging nations grow even further when the kind of concept of a smart city becomes more realistic? Is it less accessible, I guess, for developing nations to the kind of developed world? And the question here really looks at the cost. So the cost for storage, the cost of the technologies itself. Are we going to widen that, the kind of divide between developed and non-developed nations with the concept of smart cities? And can the developing nations actually use these technologies as well? Would anyone like to answer that question?
Yeah, I'll just come in, Daniel. It's Steve.
Steve.
Just from I mean, from an architecture point of view, when we look at smart city or safe city, typically you have some form of platform, and then you've got this ecosystem of different technologies that are integrated and merging into one. I think from a sharing perspective, you can share that technology across a wide geographic area, so there's better visibility, or there's increased visibility, and probably a better usage of the actual technology that's deployed. From a storage point of view, I'd like just to state that as systems do start to grow, we talk about this scalability. As you start to scale up typically in video surveillance, although there's a lot of other technologies that sits in parallel. But as you start to scale up in terms of, camera numbers, increase in technology, analytics deployed at the edge, increased retention time, and so on and so forth. One of the key takeaways for shared storage, so whether you're looking at network attached storage or SAN or clustered storage, is the fact that you can actually lower your total cost of ownership, because effectively what you're doing is putting in one single storage pool. And you can also use things like thin provisioning and various other technologies where you can actually start fairly small and just scale as you need it. But the key takeaway here is that the total cost of ownership is actually reduced. And, we're moving away from this sort of siloed approach of, you have an appliance, everything's basically loaded into your appliance as far as your VMS, your storage, your compute and everything. The issue with that is as you start to scale, the only option you've got really is to buy more appliances. And also you then introduce single point of failures as well. So it's not really a practical way forward. So the sharing of technology and also the sharing of data storage, it offers more flexibility, it offers more redundancy, it offers more resilience, but it actually lowers the total cost of ownership. So from a cost perspective, to actually adopt these types of technologies, the power of that ecosystem can actually bring a commercially viable solution to market. So hopefully that's answered at least part of your question.
Yes, thank you, Steve. I just want to talk a little bit about the scalability element that you touched upon there. So, and one of the kind of core elements of the presentation that I was noticing was the use cases for edge computing, edge technologies. When it comes to edge computing, how secure are these technologies to cyber attacks, and what kind of improvements can edge computing bring to a smart city?
Yeah, I mean, when we talk edge, I know we use this terminology edge to core, and we also use another term which is called data gravity. The reason why we say edge, or, I'm no expert on edge computing, by the way, Daniel, so I'm not even going to go there. But from an edge perspective, what we're seeing with types of smart city, safe city, video surveillance deployments is that traditionally video surveillance is very much an edge driven application. you can, tens, hundreds, thousands of devices, which is what we call end devices. So these are the devices that are effectively producing all the actual data, your cameras, your alarm devices, edge analytics, so on and so forth. So the ingestion point typically is at the edge. So when we say edge to core, typically if you're producing huge amounts of data at the end device, you want to basically ingest that data at the edge. But then we look at, if you're going to analyze that data and take some of that data out that's really important and you can actually use it at some point in the future, we then look at how companies or enterprises move or migrate that data into a more back-end cloud infrastructure. And I know Zubair touched on this before about latency and so on. Now we're actually investing in a lot of other technology. You'll start to see other technology from Seagate under the live portfolio, and this is all surrounding private cloud, hybrid cloud, data transport, data migration. And this is typically looking at how we move data, large data sets from point A to point B. Now, point A could be an edge, remote site. Point B could be private data center or some form of cloud environment. Now, from a security point of view or cybersecurity point of view, it's very much about the actual, the IT policies and the governance behind that. Seagate's point of view is, part of that security element as far as hardening your solution. We do offer a solution built around Seagate Secure. So we have a Seagate Secure portfolio, and typically this is self-encrypting drives where we actually encrypt the data coming directly into our spinning disks. So this is an industry standard encryption. But again, it can actually help with that, cybersecurity and governance and, general, data security across, very large systems. So yeah, I mean, we're not experts in cybersecurity, but what we can do is offer security hardening features inside our existing technology that also addresses them concerns in the market.
Thank you, Steve. Yeah, I like the approach there that Zubair was talking about, the kind of hybrid model of using edge computing technologies alongside the wider benefits of cloud technology. And if you can marry the benefits of those up, it's for me a really innovative, secure approach.
Well, most enterprises over the years, have migrated to cloud. They've migrated their data, whatever that data looks like, they've migrated that data to cloud. Video surveillance is lagging behind, and I know there's arguments for and against, but it's a viable option now. There's a lot of technology. In fact, we're working with Network Optix currently on data migration or data transfer from local site into our Cortex object store solution, which typically is going to be like a private hybrid or on-prem private cloud solution. So, depending on the environment, depending on the remote sites, depending on connectivity, moving data from edge to core is definitely a viable solution with inside video surveillance. And that will only grow over the coming years, especially when, we're seeing the introduction of 5G, better connectivity between, remote sites and data centers and core infrastructure. So that's only going to accelerate over the coming years.
Thank you, Steve. I've got kind of one more question here around one of the statistics that was on screen, and one of the audience has questioned whether or not 89% of CPU load is too high, and if that's sustainable or not. Does anyone want to kind of rebuttal that comment at all? Any kind of wider information you can give to that point? James, would you like to jump in there?
Yeah, as it was our test, I'll jump on that one. Yeah, I mean, the main purpose of the test, right, was to actually see how much data we can transfer through to Seagate storage arrays. So yeah, 89% is definitely is too high. You don't particularly want that. I mean, it can last long term. But realistically, we would never recommend to put 1,000 cameras on a single server, right? Especially like with redundancy and fault tolerance. This was purely a data test to see how much data we can push through from our system through to a Seagate array. And that kind of ties into the edge computing question you mentioned before as well. We do a lot of work with edge computing. As Steve mentioned, we're currently working on different ideas on how to kind of replicate that data to cloud storage. So the idea of edge obviously is that you get that distributed architecture where you kind of lower your CPU usages, your RAM usages, your network usages, because everything's kind of done on a small device at the edge, and they can all kind of health monitor each other and take over for each other to kind of make a cluster versus like having 1,000 cameras on a single unit and having 89% CPU usage. So yeah, that's definitely, our architecture is designed more towards that kind of edge computing and then pushing all the data back to a central repository. But like I said, the testing that we were doing was mainly about how much data can we get from our system through to the Seagate system, not framed. So yeah.
Okay, thank you. Thanks, James. Yes, I've just noticed a question come through from Emir and Steve has commented on there around will the storage and AI, is it going to become more affordable in the near future? And I kind of agree. It's a bit of a niche product at the moment, but there are so many use cases for these products as well. So does anyone have a kind of rebuttal on that? Any kind of insight onto the affordability of these technologies now and potentially in the future? Rob, would you want to chime in there?
Yeah, certainly from the AI side of things. Yeah, so I think without a question of a doubt, as with all things, you know, the cost is definitely coming down. So we've seen this kind of explosion in what's termed AI. AI really as a term tends to just reference whatever is quite difficult to do from a computational standpoint at that particular moment. And so the difficult tasks like detection and classification, anomaly detection, things that are at the sort of bleeding edge of the research, you know, there is this kind of jump from academia and research into a commercial product, and that's quite a big gap, you know. So the research is typically on a known data set. It's a small problem. It doesn't generalize well to the kinds of examples or practical scenarios that we want to put it in. So there is a lot of research, a lot of development that needs to happen to take that model that detects people from your Google images to a good, reliable model that detects people at 200 meters, you know, in the night on a rainy day in the middle of your city, for example. So there is a big cost involved with that, and a lot of that cost is static in so much as it's a one-time fee. The model becomes good, and the data is there. We've annotated it. We've paid the cost of that kind of development, and we retain that advantage for the long term. You know, and we can incrementally improve it, but ultimately that cost is paid. And so typically what we'll see is that the cost per channel for these kinds of algorithms comes down significantly, and even so much, I mean, we have a perpetual licensing policy, for example. So it's a one-time fee. You don't have to carry on paying as a monthly thing unless you want to, for example. And there's no upgrade costs in that. And I think that's quite a generic model across a lot of these algorithm development teams, because, you know, once we've got an algorithm that works well, it's just a maintenance cycle. And so I think overall, the new technology will continue to be expensive, but the actual algorithmic cost is low. And of course, the other side of that is the hardware. By computing on the edge, for example, which is now much more possible. You know, it's not so much now a case of if I want to run 4 cameras, I have to have a $10,000 server. It's now very much I can run a lot of these algorithms on my camera, for example. And so, you know, you combine that cost of your monitoring and your surveillance with your algorithms and your computing at the edge. And it's, you know, it's a much more distributed cost. It's a much more scalable cost approach. And so, yeah, that will only come down, I think.
Just from one point, Daniel, from my side is from a video surveillance perspective. Some 20 years ago, people, most of the customers used to record continuously, because in those times, there was no advanced technologies. After a few years, then came a new technology which was built into the camera by the name motion detection. So people started adopting it. So they were only recording when there is any sort of motion around it. So that obviously, when you compare recording everything and recording only on emotion, obviously there is a lot of cost saving involved because the consumption is less. Now, with the latest trend of more and more people looking towards advancement of AI technologies, more and more people are exploring the usage of it. Obviously, with more adoption of latest technologies in place, obviously the storage will become more smarter in terms of the capacity consumption.
Okay, thank you. And Jermaine, was there one final
Yeah,
comment
yeah.
you
I
had
was
around
gonna
costs? Yeah.
just add as well. Thank you, Dan. Just add as well that you know, I think if you look at the curve of cost per terabyte, right, that the storage industry has been delivering, you know, for years and years and years, the trend has been, you know, has been going down. And I think it's an incredible kind of delivery from the industry, right, to keep on finding ways to bring the cost per terabyte down. And actually, Steve mentioned earlier that right now, if you're looking at employing or using some of these kind of technologies for the future, you really got to think about what the true cost, right? It may seem a lower cost to upfront go buy a single DVR, you know, with some software and a hard drive in it. And then when you need another one, you buy another DVR and more cameras and another DVR. But actually, if you can think about the longer term play, the storage solutions that we're offering now, where you can have 12 bays, you can have 84 bays, you even supply a 106 bay storage unit, where you can populate it with just a few drives, even mix and match drives, different capacities, and then you're able to scale up with just the drive going forward. Actually, as Steve mentioned before, the total cost of ownership is actually better with these storage solutions. And as we continue the device cost per terabyte down, and we introduce these now total cost of ownership solutions, I think we will make the cost more attractive and appealing for those markets where, you know, cost is really sensitive. Thanks.
Thank you, Jermaine. So that pretty much wraps up the questions here. We've got one final point here around attendance at Intersec in Dubai in January 2021. And I think I can speak on behalf of most of the panel here that if COVID restrictions do lift, everyone would love to be visiting these countries and these events in person. So yeah, it's all up to the governments, and if we can get to these events, it would be fantastic to do so. So yeah, as I kind of said, it pretty much brings us to the end of the presentation and panel session. I'd like to thank Jermaine, Zubair, Rob, James, and Steve for their insights, and particularly Jermaine for hosting the questions here. Thank you all to everyone on the line for tuning into this Security Middle East magazine webinar. And any other questions that you have, please feel free to reach out to the panelists. We have provided the contact details in the chat function. So please do ask questions to them. Please do look on their websites and try and understand their product in a bit more detail. But from all of the team here, thank you very much for joining us. And we look forward to seeing you again at the next webinar. So thank you very much for your time, and have a healthy and safe week. So thank you very much.